So previously you saw me build a low speed wet grinder, and before I move on, I'd like to quickly focus on my other grinder. This is my Ryobi bench grinder, which I've had for the past, 15 years or so, and as far as bench grinding goes, it's okay. It does the job, but it is missing a pretty important feature, and that's the cover for the grinding stone. It's a bit of a safety concern for me. If the wheel was ever to let go, so to speak, I want it to be encased in a cover just to catch any of the debris. And that's pretty much why every grinder seems to come with one. And this one was no different, except it rusted out years ago, and I've been meaning to make up a replacement one ever since. Nothing too fancy, just a few pieces of TIG together sheet metal. But for my design, I'm going to need to roll a piece of steel into a ring, and I need a tool to do that. A ring roller, if you will. And it's probably quite obvious that I don't have one, but I'm pretty sure I can throw something together to get the job done. So I've had a bit of a think about it, and the design I've come up with is based on using this 1/2 inch steel plate. I have tons of offcuts to work with, and this should be strong enough. So the first thing I'll do is I'll get a few pieces cleaned up in the mill, just doing both ends and the bottom faces. For this design, I don't think it's hugely critical that I fly cut all the faces, plus I don't have any inserts for the fly cutter, so I guess it all works out. And those are the pieces of steel plate cut to size. Now the way that I intend for this to work is I'm going to have two pieces of steel sit on top of a base plate, and that's going to be the ring roller itself, and it's going to be welded to a sort of subframe on the bottom. Now the subframe is going to make it a bit more stiff, but its main job is going to be to allow me to hold it in the vise when I intend to use it. These things are normally bolted to a workbench, but since I'm only going to use this once every, say, few months, I see no reason to actually bolt it to a workbench because, it's going to take up more room that I don't really have. So at least to me, holding it in the vise makes a lot more sense. I've also done a quick outline sketch of the basic design, so I can roughly get the hole positions down and marked out. Normally I do a quick sketch up in SolidWorks, but not this time. Now in terms of design, from what I can tell, there's two main types of ring rollers. One where the outer wheel sort of moves, or I guess pivots, and you do that to change the diameter that you're rolling. And there's also a type of ring roller where the middle roller moves up and down, and the two other ones are fixed. Now having looked at a few videos, it seems that both of them seem to work just fine, but the one where the middle roller is the one that moves, it seems to be a much more straightforward design. The only real downside I can see is it leaves you with larger flat spots than the other type. I've also seen designs that incorporate gear trains to get sort of a mechanical advantage, so you don't need as much force to bend the metal, but from what I'm designing this to roll, I don't think gearing is going to be all that necessary. So at least to me, when it comes to choosing what design to go with, it seems to mostly come down to what you're actually going to be rolling. If you're going to be rolling thick or thin metal, or if you're going to be doing this a lot. But for me, I'm not going to be using this a whole lot, so I'm going with a simpler, more straightforward design. Anyway, I'll get the two pieces into the milling machine, and I'm going to get some holes drilled. Four of them are going to be for a set of cross members, which are going to be the things that actually hold the thing together, and the other ones are going to be for some roller pins. The roller pins need to be pretty spot on, so I'll bore them to the correct size. And finally, I'll make that centre hole a slot. Okay, so that was going pretty much perfectly, except I made one small mistake. When I drilled the top two holes, I used the incremental button to set the coordinates, and I forgot to set the origin. So pretty much those two holes are going to be offset by 5mm. Now that probably wouldn't be an issue because this was all set up to be done in situ, except I did the counterboring beforehand, so those holes don't line up. Now thankfully this isn't going to scrap the project, I can work around it, but that is a little bit annoying. I'll now get the cross pins made. I'm not exactly sure if concentricity is super critical here, but just to be safe, I'll swap out the 3 jaw for a collet chuck. And making these should be relatively straightforward, just 2 registers on each side and then I'll tap each end for M8. And done correctly, they'll look like that. And then the build should come together like so. Again, I do want to point out, these are the things that are going to be giving it its rigidity. The base is going to be there, but these are what's actually going to be doing the main job. Now, I need to make the pins that the rollers are going to spin on. The 2 bottom ones are relatively straightforward, and I can do them in the collet chuck. Just 2 registers on each side, just making sure that they're pretty on size. And making the moving roller is pretty much the same process, except it needs a few more cuts so it can fit into the slots that I machined earlier. It's also a little bit too big to fit in the collet chuck, so I'll use the 4-jaw. Now I will admit that this is probably the more weaker part of my design, because if it's not spot on, it might bind, but I was pretty careful to get it spot on. And thankfully the final fit was pretty good. With the moving pin now made, I now need a way of pulling it downwards so it can actually pull into the metal and roll it. Now there are a few approaches to doing this, but all of them involve a bolt of some type, and it just varies based on where you put the threads and if you do or don't make the bolt captive. I'm just going to keep it as simple as possible, and I'm going to go for the bolt through the middle approach. So what I'll do is I'll drill a hole for an M12 bolt, and then I'll counterbore the top for a small spacer. And with that done, I'll get the matching hole and also the mounting bolts for the bottom done in one go. So what I'll do is I'll glue the piece of steel in place and then get all the holes drilled and tapped in situ. Now that seems to be working just fine, but I am going to make up a spacer to sit in between the bolt head and the rod. This way when I tighten it, the bolt head is going to remain above the plate steel. And finally, I'm going to make the rollers themselves. Now the bottom two are going to be made from just regular mild steel. Now I know mild steel isn't going to be the perfect match because the pins are going to be made from mild steel as well as the rollers, and all that friction under load has the potential to gall the surfaces up. Pretty much rip that soft steel to shreds. Now if I had more bronze, or at least more than I have here, I could add a bushing, or I could harden the roller and the pins to avoid galling. But given the frequency that I'm going to be using this, and given the loads, I'm pretty convinced that galling isn't going to be a huge issue. The drive roller is also going to be made of mild steel, but I'm going to add some knurl patterns to it. It should help bite into the steel and should help it move through the rollers. I've also seen some designs that have all three rollers knurled, but those seem to be when there are multiple rollers that are being driven, which isn't the case here. And that's the rollers on the pins. I know I don't have a handle on it, but just feeding in a piece of aluminium by hand, and I can already see it working. And I think because the aluminium is so soft, it is picking up some of those marks left by the knurls. So I think if I'm doing softer stuff, I might need to make up a separate roller that doesn't have any knurls. But at least so far, the results are pretty promising. So what I need to do now is add a handle to the driver roller, and then add a groove at the end of the roller pins for some circlips. These should stop the rollers from wandering off. And last but not least, I'll weld the subframe together. Alright, and that's the bender all put together. I do apologise if it looks a bit more basic than some of the other designs out there, but then again, this was a pretty unplanned project, and I doubt that it's going to see a whole lot of use. But for a few bucks in scrap steel and a few hours of work, I think it came out pretty alright. I have made sure to oil up every surface that has sliding contact, just to make sure nothing galls up. I doubt that it would, but just in case. Anyway, let's see if it works. What I have here is some 25 by 3mm mild steel, which is what I built this to roll. Okay, so that wasn't too bad. No real need for a larger handle or gears, which is a good sign. And it doesn't look like there are any heavy marks left from the knurls. It also came out pretty straight, in the sense that it's not bending more to one side than the other. So in that respect, I'm pretty happy. The only real downside are the flats, but I think with some practice, I might be able to feed them through the roller and get them rolled too. The rollers have also held up quite well, considering that they are only soft mold steel. Now, I didn't really build it to do this stuff, but let's try some 32 by 6mm hot rolled steel, and fingers crossed I don't break it. Now, that is definitely a lot harder to do than it was before. It's a lot slower and it's taking a lot more force. But thankfully, we are making progress. In the end though, it still came out quite fine, although it has considerably work hardened. If I needed to roll it any further, I think it would be worth considering sort of annealing it or normalizing it in the furnace to make it a bit more ductile. In fact, by the end, the work hardening was getting so bad that it actually stripped some of the knurling off the wheel. Now granted, it is only mild steel, so maybe it's worth using tool steel or something that I can harden in the future. But apart from that, the rest of the build held up quite well. Now at this point I would start working on the cover, but as it turns out, I've just run out of argon, so that is going to have to wait for another day. And that's about it for now. I hope you enjoyed this video, thank you very much for watching, see you next week.